Okay, so welcome to video number 2. In this one we're going to explore some of the coordinate plane and some equations and inequalities that have two variables, an x and a y. So just as an intro, I want to talk about the coordinate plane a little bit and talk about some of the key features, which are the origin, the x and y axes, and the 4 quadrants. So the origin, first of all, is this point here where the two axes meet. So we do call it the origin, or we can talk about it by its coordinates, which are 0, 0. Now these two straight lines are number lines essentially. We call these the axes. The horizontal is called the x-axis and the vertical is called the y-axis. And when we split the coordinate plane up using these two axes, we have 4 sections. We call them quadrants. We label all of the quadrants always using Roman numerals 1, 2, 3, and 4. So we start here in this top right. This is called quadrant 1. And then we proceed around in a counterclockwise motion. So quadrant number 2 is on the top left, quadrant number 3 is on the bottom left, and then quadrant number 4 is on the bottom right. Now, any points that we want to plot, I can mark the location of any spot in any of these 4 quadrants using the coordinates, and we always see parentheses and then an x, a comma, and a y. So for example, down here we can see x and y. So my x-coordinate is -3, my y-coordinate is +5. That means I go to -3 along the x-axis, which is right about here, and +5 along the y-axis. And where those two grid lines meet, this is going to be the point whose coordinates are -3, 5. So that's just a little intro into the coordinate plane. Now that we remember, familiar with that, we can talk about some equations. Now we have 3 methods that we can use for graphing equations. The first one is just a table of values, pretty basic. I can choose values for x, we plug into the equation, and we get corresponding values for y. So I can really choose any values I want for x. I tend to pick some convenient ones, something like -2, -1, 0, 1, and 2. Those are pretty common values to choose. And I'm just plugging them into this equation here. So whatever x is, the opposite of that is going to be y. So if x is -2, y is going to be then +2. If x is -1, y is +1, and so on. When x is 1, y is -1, and -2. So I've got these points here. And each one, x and then y together, meaning the coordinates of a point. So one point on this line is -2, 2, and I can kind of draw in that point here. -1, 1, here's that point. 0, 0, so I'm just plugging in each set of points. Here's 1, -1 right here, and 2, -2. So I can keep kind of proceeding in this direction, or I can just go ahead and connect all of these points with a straight line. And so here's my line, and we are going to be graphing a few lines on this set of axes here. So I want to make sure I label this as well. So this is my line y equals -x. Okay. Proceeding on to the next method we have for graphing lines, we can look at the x and y intercepts. Intercept meaning the place where it crosses the axis. So the x-intercept is talking about the place where it crosses the x-axis here. And what we know about the x-axis is that all of my y-coordinates are 0. So if I plug in 0 for y, I'm going to get the x-intercept. So I'm going to take this particular equation here, 3x plus 2y equals 6, and I'm just going to go ahead and plug in 0 for y to get the x-intercept. Okay, so 3x plus 2 times 0, that's going to give me 6. So the 2 times 0 is just 0, and we're left with 3x equals 6. And if I divide by 3, then x is equal to 2. That means that 2 is my x-intercept. At 2 on the x-axis, that's where this line's going to cross. Now, one point isn't enough to graph a whole line, so I also need a y-intercept. And to get the y-intercept, just like in the x-intercept, I plugged in 0 for y. In the y-intercept, I'm going to plug in 0 for x. So here we go. So 3 times 0 plus 2y is going to be equal to 6. 3 times 0 is just 0, so all we have is 2y equals 6. And divide by 2, so y is equal to 3. So positive 3 on the y-axis is going to give me my y-intercept. So here's positive 3 on the y-axis. Okay. And so my straight line is going to go through those 2 points. So I can maybe graph a nice straight line through those points. Okay, go back down this way in the same kind of direction, make it nice and straight. And we want to make sure that we've got arrows on the ends. And we'll label this guy as well. So this is 3x plus 2y is equal to 6. Our third method, and probably actually the most familiar method even, is putting into slope-intercept form, finding the y-intercept and the slope. So as a reminder, slope-intercept form looks like y equals mx plus b, where m is going to be the slope of the equation, and b is going to tell me about the y-intercept. So in this particular equation, though, we don't have it set equal to y yet, and that's what we need for slope-intercept form. So we should start there. We'll start by putting this into slope-intercept form. So what I'm going to do is subtract this 1/2 x term on both sides. And so I get y equals negative 1/2 x plus 2. So now my equation is in slope-intercept form. And so now I can go ahead and use that information in order to graph the line. So I've got the information that that the equation is telling me is that my slope is negative 1/2 and my y-intercept is 2. So we use this to graph the line by saying first, okay, my y-intercept is 2. So 2 on the y-axis is where I'm going to graph my line. And then my slope is negative 1/2. Now slope we might call rise over run, or change in y over change in x. So the change in y is negative 1. That means I'm going to go down 1 unit from here. And then the change in x is positive 2. So if I go over 2 units, here's the next point on my line. And I can continue in that same pattern, down 1 over 2, down 1 over 2, down 1 over 2, and so on. I can also go back in the other direction, so from my y-intercept I can go up 1 and to the left 2, and kind of continue this pattern. And once I feel like I've gotten sufficient points here, I can go ahead and just graph my straight line through all of those points, and again I'm going to label that as well. So there's my y equals negative 1/2 x plus 2. So 3 methods we've got now to graph straight lines. It's pretty good. Now, in addition to graphing lines, we also want to know how to write the equations of lines. So I want to just reiterate once again the equation of a line in slope-intercept form. Okay, so m is the slope and b is the y-intercept. Now, sometimes we're really lucky and they give me that information to start with. So in this first problem, it says m is 1/3, that's my slope. Y-intercept is positive 4. So we've got right away y equals 1/3 x plus 4, and we're done. So this is kind of nice when they actually give me all of that information, but it's not always going to be the case. So another option is that they give me the slope and also some point that the line passes through. I don't know the y-intercept. I'm going to have to solve for it. So we can start out by kind of writing the equation of the line y equals mx plus b. I can plug in my 3/2 for x. But because I don't know b, I can't plug anything in there just yet. What I do know, though, is that I've got this point 4, 1, and I know points always come in x, y kind of format. So I know that when the x value is 4, the y value must be 1. And so I can actually plug these things in, plug in 4 for x and 1 for y, and then actually solve for b. So 3/2 times 4 plus b. Now 3/2 times 4, if I actually multiply that, we get 6. And then I can subtract 6 on both sides, so we get negative 5 is equal to b. So now I have a value for b, and I have the slope, and so I can write the equation of my line y equals 3/2 x minus 5. Okay, there's my equation. Okay. Another option is that we actually have not the slope at all, but just 2 points that the line passes through. Now, once we have 2 points, we can find the slope. And so you are going to want to kind of remember, take down the slope formula, which is y2 minus y1 over x2 minus x1. And again, sometimes we have that written in another way as the change in y. That's a little triangle. It's the Greek letter delta over the change in x. Or you might also have heard it called rise over run. But when I have 2 points, we kind of look at it this way, because I can say now this is going to be, say, x1 and y1, and here's going to be my x2 and y2, and so I can plug in and actually figure out what the slope is from these 2 points. So let's go ahead and do that. If I plug into the slope formula, m equals y2, that's 3, minus y1 is 6, over x2, a 2, minus x1, 0. And simplifying this, we get 3 minus 6 is negative 3. 2 minus 0 is 2, so here's my slope. Now we're back to the situation we had in that last problem where I have the slope and I have points. I can choose either one to plug in and find my b value. So now I've got y equals negative 3 halves x plus b. And I'm going to choose the 0, 6. Plugging in 0 is always nice, so I like to choose it when I can. So I have 6 is equal to negative 3 halves times 0 plus b. Negative 3 halves times 0 is just 0, so that leaves me with 6 equals b. And so once again, I've got my y-intercept and my slope, and I can write the equation y equals negative 3 halves x plus 6. Another situation we might come across is trying to write the equation of a line from a graph. So again, the key pieces of information we want to know are the y-intercept and the slope. Now looking at the graph, you should be able to see where it crosses the y-axis. So I can see this point right here looks like my y-intercept, and that looks like it's exactly positive 1. So we're going to say b is equal to 1. I also need to know what the slope is. And remember, slope we said is change in y over change in x, or rise over run. So I want to choose another point that I can read here, another point that looks like it goes exactly through the grid points. And I want to find out what is the change in y from one point to another, and what is the change in x. Okay, make that look like a little bit more like a y maybe. Okay. Hang on. Ooh, that's sort of better. It says change in y over change in x. You got it. Anyway, so if I go from one point to another, I'm going to go from the red point to the green. So the change in y, we have to go down 1, 2, 3 boxes. So the change in y is going to be a negative 3. And then the horizontal change, the change in the x values, I'm going to the right one, so positive 1. So my slope is negative 3 over positive 1, or just negative 3, we can write that as. And so now, again, I've got my slope, I've got my y-intercept, and so the equation is y equals negative 3x plus 1, and we're good. Okay. Finally, our kind of special types of lines are vertical lines and horizontal lines. And I definitely want to make sure I remember the pattern for those. Okay, so handy kind of mnemonic, a good way to remember vertical and horizontal lines we talked about is Vux and Hoy. Now Vux and Hoy sounds kind of crazy, but if you can remember it, it will help you not only know what vertical and horizontal lines look like, know what their equations look like, and also know what their slopes are. So Vux, we remember, stands for a vertical line, has an undefined slope, and looks like x equals some number. So if I, for example, saw a vertical line and I wanted to write the equation of that line, okay, well, because it's vertical, I know that the equation looks like x equals some number, and then all I have to do is count how many boxes over it is. So let's say this were x equals positive 3. That would be the equation of that line. On the flip side, horizontal lines, Hoy, horizontal line says 0 is the slope, and y equals some number is the equation. So again, if I wanted to say maybe graph a horizontal line, okay, if I had the equation of that line, if I knew the equation was y equals negative 1, say, Well, I know that y equals -1 is a horizontal line because it's a y equals. And then I just go to -1 and I can draw in that horizontal line. Okay, so Vux and Hoy, good way to remember vertical and horizontal. Whew, moving right along. Now we can do inequalities now that we've got straight lines down. Okay, so graphing inequalities is a lot like graphing straight lines. First thing I want to do is get y by itself, so it looks like y equals mx plus b. Then I can plot points just like if I had it in slope-intercept form. And then when I connect the line, when I connect the points, I want to just make sure I use the correct type of line. So I can use dotted lines if I've got just a less than or a greater than, no equal to. Or if I do have the equal to sign, I know I can use a solid line then. And then what we're going to do is finally choose a test point so that I know where to shade, because I do want to shade half of the graph, either above or below the line, or either to the left or the right, depending on my test point and the results there. So I'm going to graph this inequality, -3y is greater than -x minus 6. First thing I'm going to do is isolate the y, get the y by itself. So I'm going to divide by -3 on both sides of this equation. Now, if you remember, when we divide by ooh, that was weird. Sorry. When we divide by a negative number, I want to make sure I flip my inequality. That still holds from last time. So we're going to get then y is less than, and -x divided by -3, so this is going to be positive then, positive 1/3 x. And -6 divided by -3 also is going to be a positive 2. So I've got y equals 1/3 x plus 2, which is now in y equals mx plus b form. So I can look at this and say, okay, well then my slope is going to be positive 1/3. My y-intercept is going to be positive 2. So positive 2 on the y-axis, this is where we start. And then from here, remember slope is the change in y over change in x, or the rise over the run. So I'm going to go from this original point up 1 and to the right 3. That's going to give me another point. And up 1 over 3. And we can again go back in the opposite direction and also get some more points on this side. And once I've got enough points, I can use my straight edge and connect the dots. Now again, going back to the original part of the problem, though, I want to make sure that I'm using the right type of line. This is a greater than but not an or equal to, which means I'm going to be using a dotted line to connect my points. Now the last piece that we need is to know where to shade. So I'm going to choose a test point. You want to choose something easy because you are going to be plugging this in yourself. I like to use 0, 0 when it's available to me. I can use any point that's not on the line itself, so 0, 0 works for me today. And so if I want to test the point 0, 0, okay, I remember this is x, this is y, so this is what I'm plugging in. And I want to plug back into the really original problem here. -3y is greater than -x minus 6, just to make sure that I haven't made any mistakes on the way through. So -3 times my y value, which I'm plugging in as 0, should be greater than -x value is also going to be 0 minus 6, and I can simplify. So this is 0 on the left side. 0 minus 6 is -6 on the right. So this is a true statement. 0 is, in fact, greater than -6. And what that means is that I do shade on the side where the test point was. So in this case, that's below my dotted line. So I'm going to just shade in down here. And that's my inequality, and I'm all set. Good job, guys. 2 down.